Hello everyone, welcome to our class, Revit for Rebar, why BIM is better for concrete. My name is Tomasz Fudala. I'm the Technical Marketing Manager for Structure at Autodesk. I have the structural engineering background and my area of expertise at Autodesk is structural engineering. I mean structural design and analysis, code checking, as well as detailing and fabrication. I'm really passionate about computational design, about Dynamo, especially how it can be used to automate engineering workflows. I always like to begin my class with a reminder what you signed up for. Today, you will learn about the differences between CAD and BIM, as well as understand the benefits of modeling reinforced concrete structures in Revit. Then you will learn about key Revit features for reinforced concrete. You will get familiar with possibilities you have when it comes to automation of the placement of rebars when performing rebar detailing. And finally, you will learn how to save time through streamlined review and approval workflows. Let's get started. CAD has been an important part of the AEC industry for decades. In the early 80s, CAD was a significant innovation that radically transformed documentation efficiency for the industry. CAD has helped move the AEC industry far beyond manually produced paper drawings, enabling us to produce more complex and accurate designs. CAD programs are still in widespread use by engineers and detailers across the world. But today, the AEC industry faces new challenges. Financial constraints, for example, are placing the entire AEC industry under increasing pressure to deliver projects more quickly and accurately. As a result, AEC firms are looking beyond CAD to find a solution. These are types of challenges addressed by BIM. Many of you may be thinking, okay, but what exactly is BIM? BIM stands for Building Information Modeling, and it is an integrated process of creating and managing information for a built asset. It is a process for exploring a project's key physical and functional characteristics digitally before it is built. The coordinated, consistent information used throughout the BIM process helps architects, engineers, contractors, civil engineers, and owners to see and understand prior to construction what their design will look like and, more importantly, how it will perform. Now, let's take a quick look at one of the major differences between AutoCAD, a well-known CAD software, and Revit, a popular BIM authoring software. Naturally, this discussion could lead us down many paths, but I would like to start with the fundamental differences in the workflow. With all its tools and sophisticated features at its core, AutoCAD is essentially a digital drafting board. It doesn't fundamentally change the basic drawing workflow utilized by many design professionals in any noticeable way. In other words, before you create drawings in AutoCAD, you have to decide what kind of drawing you are making. Are you making a plan or a section? If you want to create a plan, you begin creating a series of lines and curves to represent your structural design specifically as a plan. You then need to repeat this process to create a section or some other kind of drawing that might be required. In some cases, you can copy and reuse parts of your drawings, but these copied elements are not connected to one another in any way. When changes occur to your design, you will have to update each drawing individually to reflect those changes. In Revit, the process is fundamentally different. Instead of drafting individual drawings, we build a single representation of our structural model. This model is created from a collection of well-known structural components such as columns, beams, walls, slabs, foundations, and of course, rebars. Each of these elements has its own settings and parameters that establish the kind of object it is meant to represent, and the entire group of structural elements comprises a single model. This model may be viewed in plan, section, elevation, 3D or schedule views as designed, and users may define rules for each of these view orientations to ensure they match individual firm standards. It is important to understand that in Revit, these views are not separate drawings, but simply different ways of looking at the same model. At a glance, it may seem that AutoCAD and Revit approaches are similar, but the result is completely different. The use of model-based approach in Revit means that when a change is made to any view, the change is immediately reflected in all views. The views cannot fall out of sync, as they are all simply live representation of the same model. Additionally, using a BIM-centric solution allows users to design and detail with clash prevention in mind to reduce clashes both in the pre-construction and site execution project phases. Using a BIM approach with Revit, we create a federated building information model and aggregated assembly of distinct models for each discipline, comprising a single complete model of the building. A single federated model is useful for design coordination, clash avoidance, and clash detection, approval processes, design development, estimating, and so on. The individual models are maintained as separate files with clear authorship and scope definitions, but they are able to be brought together as needed. These are fundamental differences between AutoCAD and Revit. For many firms, these represent the primary benefit of using BIM over CAD. Building information modeling, BIM, is a critical part of how structural systems are designed and built today, but the reinforced concrete industry has been lagging behind structural steel when it comes to its adaptation of BIM. This is due to the highly fragmented nature of its supply chain, which requires a number of different designers and suppliers to collaborate and simultaneously deliver the final product. When we ask our users what they want to see in a BIM-centric solution for concrete, we often hear a variety of answers that differ drastically depending on someone's role on a project. Engineers and designers, they want to gain more engineering insight while creating the design intent of structures, seamlessly coordinating with the assistance of analysis tools and local building code requirements. Fabricators want to maximize production and delivery efficiency while minimizing the time spent on detailing and coordination with the field. Contractors want to optimize planning and estimating tasks by determining accurate quantities in the early stages of a project, thereby streamlining their installation process to avoid rebar clashes on site and coordination with other trades. Despite the differences in opinion on the BIM solutions needed for reinforced concrete, it's clear that the industry is ripe for radical disruption. Over the last several years at Autodesk, we have made a commitment to address the opportunities our users are asking for by investing in customer-centric solutions for the reinforced concrete industry that better connect concrete design and detailing to fabrication. I bet now we would like to know what are the benefits of using a Revit-based strategy. What value does it provide to Revit users? We see BIM-centric concrete solutions helping our users in 4 main areas. This approach combines the versatility of 2D documentation with the high level of fidelity and accuracy of 3D modeling of steel reinforcement and concrete accessories with minimal effort to produce both. It allows Autodesk users to design and detail with clash prevention in mind, to reduce clashes both in the pre-construction and site execution project phases. Revit enables the transition from design intent to detailed models while respecting both perspectives, following local code requirements and automating the process of making changes so they are less disruptive to the project. It increases the transparency and quality of model information being used from bidding to procurement, but not only providing quantifiable information, but also enabling access to it in collaboration-friendly environments. Now, I would like to highlight some of the key Revit features for reinforced concrete structures. Parametric modeling refers to the relationships among all elements in a project that enable the coordination and change management that Revit provides. These relationships are created automatically by the software and by you as you work. This capability delivers the fundamental coordination and productivity benefits of Revit. Change anything, anytime, anywhere in the project, and Revit propagates that change throughout the project. There is a wide range of reinforcement tools in Revit suitable for modeling reinforcement in various situations and for different types of concrete elements. These elements can range from simple columns, beams, walls, and floors to very complex 3D double curved decks. There are many methods for adding rebars into concrete elements, and the choice of method depends on the individual user preferences or design context. For example, you can simply sketch the rebar shape. Using this approach, Revit automatically recognizes the shape code and assigns it to the newly created rebar instance. Another way is to use the library of shapes loaded into the project. You simply pick the desired shape from the library you want to use, set the placement plane, placement orientation, and rebar properties, click within the host sections, and Revit places rebar and expands the rebar shape to fill the space provided within a concrete element host by default. You can also quickly rotate the rebar simply by pressing the spacebar if needed. In Revit 2022, we introduced a new method for placing rebars. Revit users are now able to place rebars of exact dimensions aligned to any reference in the project with just 2 clicks. This reduces the number of steps needed to create the bars with the desired geometry and in the exact place. This feature is huge for rebar modeling, and it is a real game changer for rebar detailers who work in Revit. There are many methods for adding rebars into concrete elements, and the choice of method depends on individual user preferences or design context. When adding rebars of various shapes to concrete elements, you can define not only a rebar diameter, but also a type of layout or a rebar set. Using rebar sets speeds up the process of adding rebar by providing a quantity of identical bars. Having rebar sets properly defined can help your rebars properly react to concrete geometry design changes. You can define accurate reinforcement for non-standard concrete element shapes by fitting rebar for non-standard geometry with rebar sets that vary along incline faces. Moreover, you can use multi-rebar annotations, customizable numbering settings, and accurate schedules that display varying lengths. The display of varying sets and schedules can be customized by reinforcement settings. In Revit 2022, you can now move or remove individual bars and rebar sets or area and pad reinforcement systems to avoid clashes with other rebars, openings, or other elements, while maintaining the logic of the rebar set or system. There is no need to split a set into multiple sets to remove path and area reinforcement systems, workflows that were complex and time-consuming. Multiple sets or systems can be edited at the same time. A few seconds ago, I mentioned area and path reinforcement systems. These are dedicated tools for the creation of planar concrete elements. Let's imagine a situation where the wall reinforcement is already created and the detailing process, including shop drawings, has been completed. The structural designer is informed by the architect that the window opening must be enlarged and slightly moved. This is a situation where a CAD workflow would require us to perform many tedious and time-consuming manual adjustments. But let's see what happens to our reinforcement in Revit when we change the size or location of the window opening. Because we have used area reinforcement systems, our reinforcement follows the changes associated with the opening. Rebars are updated automatically and shop drawings stay up to date. Here, I have used rebar constraints too, to have my rebars following design changes accordingly. I will be talking more on rebar constraints in a few minutes. In addition to shape-driven intelligent rebars, Revit offers you freeform rebars. You can use the freeform rebar tool to model bars in any concrete host, regardless of its complexity, mostly for civil structures, but also for regular building elements where you need a set of bars following a curve or something similar. This type of reinforcement differs from shape-driven rebar by the fact that the bars get their geometry exclusively from the geometry of the host. We call this type of reinforcement host-driven. Surface distribution of freeform rebar populates the surfaces of irregular shaped hosts with variable non-planar distribution. The bars are created by interpolating between the first and last bars of a surface distribution set. Like shape-driven rebar, freeform rebar falls under the structural rebar category and contains the typical properties for this category. You can set the layout options for the set, the rebar type defining the diameter and bending radii, add hooks, and extract fabrication data. Numbering is performed automatically. Freeform rebars can also be used to create rebar sets with planar bars distributed along the faces of a structural element and aligned to a distribution path. Just like with the surface distribution type, modeling of the aligned distribution type can be done by working in 3D views and selecting the structural element faces to which the bars are aligned. Bars in an aligned distribution are created at the intersection of each individual bar plane with the host surface. All the bars are planar, respect the cover of the host, and are aligned to the distribution path. Freeform rebars increases 3D rebar modeling versatility in Revit and helps you define the accurate reinforcement for standard and non-standard shapes of concrete elements. For the concrete element to work as expected, corrosion resistance, etc., it is very important for bars to respect the concrete cover. In Revit, every concrete element has concrete cover settings defined. These settings can be managed and overridden. You can change rebar covers for the whole element at once or for individual faces of the concrete element. When placing rebar, either directly or by sketching, the bars will automatically snap to the concrete cover or nearby bars. This behavior also applies when adjusting the bars by dragging individual bar handles. To better manage accurate rebar placement distances from a concrete cover, from a face or between rebars, we have rebar constraints in Revit. Rebar constraints are part of an internal mechanism used to set and lock the geometry of each rebar instance with respect to its concrete host element or other rebars. Once the rebar's geometry is set, Revit automatically assigns constraints to the rebar so that it moves and flexes appropriately in response to changes that occur in the model. Using in-canvas tools, you can place rebar more precisely with the Graphical Rebar Constraints Manager. The user interface highlights each rebar segment that can be constrained, along with the available targets. That makes working with rebar constraints easy and intuitive. The snap constraints maintains its relationship when you place, move, drag, or copy rebar. Let's image a situation where you need to slightly adjust your concrete cover, or the element section dimensions must be updated. With the properly defined rebar constraints, this update would take you only a second. Now, let me talk a bit about the reinforcement connectors in Revit. Rebar couplers are family-based and fully customizable, and each team member can use them according to their needs. Rebar couplers interact with the rebar that they connect to, facilitating change management. Structural engineers can use schematic connectors to define requirements. Detailers can use them to produce shop drawings. Manufacturers can go into full detailed, precisely modeling and representing reinforcement connectors to create installation instructions. You can add the connectors to groups, assemblies, and partitions with unique coupler numbering, and you can export them to various formats. Revit has rebar numbering that enables identical reinforcement elements to be matched for schedules and tags. So if you add a rebar to your project, it will inherit a rebar number from the existing identical instance, having the same shape and dimensions. Partitioning for reinforcement serves several organization purposes, depending on how a building is designed or how it will be constructed. Structural engineers and detailers can create design reports, drawings, and schedules from the 3D model more easily and quickly than from 2D designs, including design efficiency. The rebar quantities produced from the 3D model are more reliable than takeoffs from a 2D drawing, leading to accurate cost projections. Quantities are also fully traceable, allowing checks and comparisons to be made effortlessly. In Revit, you can annotate individual rebars, rebar sets, or use the multi-rebar annotation feature. Thanks to this option, you can annotate multiple rebar and rebar sets with a single tag. You can use these annotations to tag each bar in rebar sets with detailed fabrication and construction information. These dimension lines and descriptions can easily be changed to any style to suit local design requirements. If rebar designs are changed, all tags are automatically updated as they use data stored in the model parameters. You can better document multiple rebars within a host, showing only a representative subset, enabling the creation of legible reinforcement documentation. This gives you the ability to create better concrete detailed shop drawings of reinforcement. The bar presentation allows the reinforcement of structural elements to be displayed in a simple, more readable way. Defining different bar presentation for a rebar set in each separate view gives you more flexibility in creating shop drawings. Schedules are a very powerful tool in Revit. They are a useful way to display model information and are essential when documenting your project. Revit provides you with a lot of out-of-the-box parameters that you can use in your rebar bending schedules, but you can also add additional ones if needed. Examples of provided parameters that you use are bar diameter, bar length, total bar length, quantity, rebar number, shape code, different bar segment lengths, etc. Once your parameters are in place, your Revit rebar schedule will list all structural rebars in your project. Then you can easily group, filter, sort all data in your rebar bending schedules Schedules are fully customizable, so you can adjust them according to your local standards. In Revit, your schedules are always up to date. Moreover, you can modify your models through these schedules. You choose how to most effectively manage your model data. There are many more powerful rebar functionalities I simply don't have time to cover during this class. Now let's talk about automation. Many of you may say that Revit features are powerful and the process of using them seem to be pretty straightforward. However, using them can be very tedious, and it takes a lot of time as we need to repeat a sequence of the same steps for every single concrete element. Moreover, some of you may add, our CAD solutions have a bunch of macros that allow us quickly and automatically generate typical rebar designs, shop drawings, and bending schedules. This is a situation where Dynamo for Revit comes in handy. So let me talk a bit about automating the process of adding rebars to concrete models. Let's see two short videos running next to each other. The one in the lower right corner shows the manual process of creating reinforcement around the window opening. This video is sped up 15 times. The second demo shows the generation of rebars for several window and door openings simultaneously using a Dynamo script that is run via Dynamo Player. The difference between the traditional manual modeling and the automated one is super clear, and the value added by the automation is incredible. In this example, I was able to speed up the concrete detailing process about 60 times. Let's talk about collaboration and the review and approval process using Autodesk Docs, a recent addition to the AEC collection. As an example, I would like to talk about the design to fabrication for structural precast workflow. Here, we have three personas: a structural engineer, a precast detailer, and a project lead. In this workflow, the structural engineer communicates design intent into the detailer. The detailer works on a detailed precast model and drawings and sends his work to the project lead for review. The project lead sends his feedback to the detailer. This back and forth process might be iterative. I have been talking about Revit as a BIM-centric solution for the reinforced concrete industry, showing you some cast-in-place concrete examples. Now, I would like to highlight some precast functionalities that you can find in Revit. In this workflow example, a structural engineer or a structural precast detailer who works in CAD has an existing library of AutoCAD details that he would like to leverage on a project that requires Revit. Using Autodesk Docs, he can collaborate with Revit users on precast designs and communicate all necessary precast connections in the DWG file format. The AutoCAD designs can be leveraged by Revit users when modeling to LOD 350 or 400 in the BIM environment. These details can be attached to the final documentation. The Precast tab in Revit supports for multiple stages of the precast workflow. It offers advanced tools that automate the process of generating precast assemblies, shop drawings, and files for computer-aided manufacturing CAM machines. Using this solution, precast detailers can perform segmentation for slabs and walls according to customized predefined rules. These tools help both fabricators and precast detailers reduce the time spent on modeling, generating shop drawings, and producing precast planar elements, offering a streamlined model-based fabrication process. The structural precast detailer can use the Publish Settings tool in Revit to select views and sheets of the model and publish them to the cloud. Once all 3D precast designs and drawings have been created, the structural detailer can share them with the project lead via Docs. Docs integrates the entire project workflow from design to construction across one common data platform. Once all published views and sheets have been posted to Docs, they are ready to be reviewed by the project lead. To ensure that any errors found in the review process are addressed, a trackable issue complete with a detailed description of the problem and a recommended completion date can be assigned to a specific project member. In this case, it's the structural detailer. Let's look at a few example issues. First, reinforcements around the door opening need to have a greater diameter. As you can see, Docs allows you to select any object and see its properties. The second issue points out that there are missing grout tubes in the precast wall. This issue can be also easily reported. The third issue identifies missing reinforcement around the opening. Markups can also be created on the sheets. Markups allow you to create visual instructions to illustrate ideas that would be difficult to convey by other means. When markups are created, they are only visible to you. To make them visible for other members, you need to publish them. Here we can see all issues that have been created by the project lead and have been assigned to the precast detailer. In this example scenario, a precast detailer has been notified by the project lead about the issues to be addressed. He will fix them in Revit and communicate back his updates. Once the changes have been completed in Revit, the structural detailer can respond to the project lead using the same tracking tool and thereby maintaining a complete and current record of the issue's progress. Confirmation of the issue's resolution can be obtained using the Compare feature in Docs. Docs offers integrated change visualization features that let users compare the changes between two selected versions of the project to see exactly what has been added, deleted, or modified. At this point, the issue can be closed and its history will be maintained in a Docs environment, where everyone on the project team will be able to see how it was resolved and who was involved in the process. Today, owners expect design and construction to be fast, collaborative, and well-coordinated. Taking advantage of the latest developments in BIM and intelligent 3D modeling for your reinforced concrete detailing is a smart way to please your clients and remain competitive. Using Revit for rebound design and detailing, every structural member can be modeled, documented, tracked, and controlled. Design changes can be coordinated easily and managed accurately. Don't wait to move to BIM. The right time is now.